Today we're going to be dividing polynomials. Our essential question for today is, what are some ways to divide polynomials? And how do you know when the divisor is a factor of the dividend? All right, now this last part we probably won't get to until the next lesson on Monday. Okay, but we definitely will learn some ways to divide polynomials. We are going to be going ahead and skipping the explore, and we will be skipping explain to. Anywhere you see the word synthetic, we are going to be going ahead and skipping those. Synthetic is a special situation that only works in very specific cases. We don't want to learn something that works in one case only. We want to learn something that works all the time. So we will be focusing on long division. And when you watch videos, be sure that if you're trying to support what you saw here, that you're only looking for ones that talk about long division of polynomials. Synthetic division is a strategy, but it only works in very specific situations. Now, when you added two polynomials, the sum of two polynomials, remember that it was a polynomial. The difference, the subtraction of two polynomials, was a polynomial. And the product, or the result of multiplication of two polynomials, was a polynomial. Today, we need to look at this situation with division. We need to see if it holds true. Now, let's just think about something with whole numbers. For example, 277 here is being divided by 12. The quotient is 23, but notice there's a remainder. So that's really 23 and 1/12. So 277, that's an integer. So it's a number without any decimal or fraction part. 12 is an integer. It's a number without any decimal or fraction part. But the result, 23 and 1/12, that is not an integer. So notice an integer divided by an integer was not an integer here. But if I did 20 divided by 5, that would be 4. So the result of two integers was an integer. If I did 20 divided by 3, that would go in there 3 times, that times 6 is 18, so you would get 6. But there's 2 left over, 6 2/3, or 6.6 repeating. And notice that is not an integer. So sometimes the division of two integers is an integer, and sometimes the division of two integers is not an integer. So keep that in mind as we're dividing polynomials. Okay, keep that in mind as we're dividing polynomials. Let's review some vocabulary that you may not have seen in a while. When I'm setting up my division, the dividend, the part that is being divided, goes under our bar. Okay, so inside, I should say. So our dividend is going inside. So the number that's being divided, we call that the dividend. The number we're dividing by is called the divisor, and so that's the part that goes outside. The result to division is called a quotient, and any part left over is called a remainder. Now, the final result to long division should look like this. It should be a quotient plus the remainder over the divisor. You're used to seeing that remainder over divisor look something like a fraction, like 1/12, or maybe a decimal. But for polynomials, that won't be the case because the divisor is not a number. All right, so this is an important setup to remember. So please make sure you know the setup, that the result to division is going to be always the quotient plus the remainder over what you were dividing by, the remainder over the divisor. All right, if you want to check your work, you just multiply through by the divisor. So when you multiply through by the divisor, you'll be left with the dividend here. You get your divisor times the quotient, and then you just add on the remainder. Because when you multiply the remainder over divisor by the divisor, you're just left with a remainder. So again, to check your answer, multiply the divisor by the quotient and add on the remainder. If you get your original polynomial, you did it correctly. In reality, will you check with this method most of the time? No. Can you check with this method? Absolutely. If you have extra time left over on a test, you should go back and check like this. If it's a timed test and you're in a rush, save it for the end. So let's go ahead and jump in and practice this division. So I have 4x cubed plus 2x squared plus 3x plus 5, and I'm dividing that by x squared plus 3x plus 1. So I'm taking a cubic and I'm dividing it by a quadratic. So notice my cubic, my dividend goes inside, and my divisor goes outside. And you now want to ask yourself, how can I make the first term in the divisor look like the first term in the dividend? And we're assuming that these are all written in standard form. Okay, so make sure they're always put in standard form. So how can I make the first term in the divisor look like the first term in the dividend? Here's my divisor. How do I make it look like the first term in my dividend? So we're trying to make x squared look like 4x cubed. Now, since 4x cubed is being divided by that, your divisor is being multiplied by the result. So x squared times what is 4x cubed? And so let's see, it needs a 4. And to turn x squared into x cubed, you need another x. So if we multiply each item in my divisor by 4x, we'll get the first terms to match. You're just trying to get the first terms to match. So what I do with this 4x now is I now distribute it to each item in my polynomial, in my divisor polynomial. So I get 4x times x squared is 4x cubed. I get 4x times 3x, and that is 12x squared. I get 4x times 1, and that's 4x. So notice I'm lining it up under the same degree term on my original dividend. All right. So now I want to subtract this polynomial. You're actually going to be subtracting this whole polynomial. But if I'm subtracting that whole polynomial, then this negative is actually going to go to each term. It's going to distribute to each term in the polynomial. So 4x cubed minus 4x cubed is 0. 2x squared minus 12x squared, that's negative 10x squared. 3x minus 4x, that's negative 1x. And then I carry down any extra terms. And so now I ask the question again, how can I make the first term in my divisor look like the first term in the remaining dividend? And so to turn x squared into negative 10x squared, I'm going to go ahead and need a negative 10. So now I get negative 10 times x squared is negative 10x squared. Negative 10 times 3x is negative 30x. Negative 10 times 1 is negative 10. And so I'm subtracting. Remember, I am subtracting. So I'm subtracting this whole polynomial. But if I'm subtracting, I distribute the negative. So when I distribute it, that becomes plus, plus, plus. So negative 10x squared and a positive 10x squared makes 0. Negative x plus 30x is 29x. 5 plus 10 is 15. I can no longer turn x squared into x. There's nothing I can multiply x squared by. There's no polynomial I can multiply x squared by to get x. I would have to divide to do that. So as soon as the degree of your dividend is smaller than your divisor, you're done. And this portion here, this is called my remainder. This is called my remainder. And this up here, this 4x minus 10, that's called my quotient. So now my final answer, I'm going to write my quotient plus I need to do the remainder over the divisor. Remember this part on the outside here? This was my divisor. So I'm going to get 29x plus 15 divided by x squared plus 3x plus 1. And there's the answer to my division problem. Now ask yourself, is this a polynomial? Polynomials cannot have variables in the denominator. Notice my final answer has a variable in the denominator. So this is not a polynomial. The answer is not a polynomial. It's still an answer, and that's okay. This is still the correct answer. Just notice a polynomial divided by a polynomial was not a polynomial in this case. Okay, let's go on to B. Now on this one, if we're looking at it, notice that my dividend is actually missing a degree. It goes 4th degree, 3rd degree, 1st degree, 0 degree. So it's missing the 2nd degree. For division, you want to go ahead and put that degree in. Anytime it's missing a degree, you put it in with a coefficient of 0. So anytime it looks like it's missing a degree, you write that coefficient in, or you write that term in, but with a coefficient of 0. So this is really going to be 6x to the 4th plus 5x cubed plus, I need x squared. But how many x squareds did I have? I had 0x squared plus 2x plus 8. So this dividend is now what goes underneath. Okay, it's what goes underneath. And then on the outside, my divisor, x squared plus 2x minus 5. So now I'm going to ask myself the same question. How do I make x squared look like 6x to the 4th? Well, I can turn x squared into 6x to the 4th if I multiply it by 6x squared. Since I multiply it by 6x squared, I have to distribute that to each item in my divisor. So that becomes 6x to the 4th. That becomes 12x cubed, because x squared and x is x cubed, and negative 30x squared. I'm going to be subtracting this polynomial. But what subtracting does with polynomials is it changes the sign of every term. I'm going to go ahead and change the sign of every term. So my first term, they cancel each other out. I get 5x cubed minus 12x cubed, and I'm left with negative 7x cubed. 0x squared plus 30x squared is 30x squared. And then I bring down my remaining term. So I bring down 2x plus 8. So now I ask myself again, how do I make x squared look like negative 7x cubed? I do that with negative 7x. So I distribute that. Negative 7x times x squared is negative 7x cubed. Negative 7x times 2x is negative 14x squared. Negative 7x times negative 5 is positive 35x. And that's it for that part. So now I'm going to be subtracting this polynomial. But remember, subtracting the polynomial is going to be changing the sign of each term in my polynomial. So 7x cubed plus 7x cubed, negative 7x cubed plus 7x cubed, they cancel. 30x squared plus 14x squared is 44x squared. 2x minus 35x is negative 33x. And then I need to bring down that plus 8. So now I ask myself, how do I make x squared look like 44x squared? Well, I'd have to multiply it by 44. So when I multiply it by 44, I get 44x squared. 44 times 2x, that's 88x. And 44 times negative 5, that's 20. 20 plus 2 is 22, so 220. So I get, but it's a negative, so it's minus 220. I'm subtracting this polynomial, so it's changing each sign. 44x squared minus 44x squared cancels. Negative 33 minus 88, that's negative 121x. 8 plus 220 is 228. My degree is now smaller than the degree of the divisor. So I am done. This is my remainder. That is your remainder. So I'm going to write my final answer with my quotient, 6x squared minus 7x plus 44 plus negative 121x plus 228 all over x squared plus 2x minus 5. And that's my final answer. If you wanted to check your answer, multiply your divisor times your quotient and add on the remainder. Now I will go through and do 3 and 4. I do encourage you, at least for 4, pause the video before I start my work so you can try it yourself first. If you feel like you're ready, go ahead and pause the video now and try number 3. Otherwise, watch through number 3 and then try number 4 yourself. So number 3, I'm going to set it up. I'm going to have 3x squared plus 6x plus 1. I am setting it up wrong. Be careful. That's your divisor. So that actually goes on the outside. I'm going to take this, but notice it's missing a term. It's missing my term of x squared. So since it's missing that term of x squared, I say it has 0x squared. Then 8x minus 12. Now I go ahead and put my divisor on the outside. 3x squared plus 6x plus 1. How do I make 3x squared look like 15x cubed with 5x? So I get 15x cubed. I get 30x squared. And I get 5x. Okay, I'm going to subtract. I get minus, minus, minus. 0x squared minus 30x squared is negative 30x squared. 8x minus 5x is 3x. And I bring down the negative 12. How do I make 3x squared look like negative 30x squared? I multiply by negative 10. So that becomes negative 30x squared. Negative 10 times 6x is negative 60x. Negative 10 times 1 is negative 10. And so now I'm going to be subtracting these. But remember, subtracting is really multiplying each of these by a negative. So negative 30x squared plus 30x squared cancels out. 3x plus 60x is 63x. Negative 12 plus 10, that's 2. Excuse me, that's negative 2. Negative 12 plus 10 is negative 2. So now my degree is smaller than the degree of here. And I'm just going to show you one more way to go ahead and write your answer. Rather than rewriting it over here, I'm just going to go ahead and add my remainder up here. So I'm going to get 63x minus 2 over 3x squared plus 6x plus 1. All right, and there's my final answer. So I'm going to go on to number 4. I do highly encourage you to pause the video at this point and try number 4 on your own. Now that you've paused the video and tried number 4 on your own, let's go ahead and set it up. So you're going to check your answer with me. So I get 9x to the 4th plus x cubed plus 11x squared. Notice there's a missing term. So since there's a missing term, be sure you had 0x in there. Be sure you had 0x. On the outside, I put my divisor of x squared plus 16. I'm going to multiply by 9x squared, and that's going to give me 9x to the 4th. Now this time when I multiply, and I get 9 times 16, 9x squared times 16, that ends up being 144x squared, not x cubed, x squared. So be sure you line up like terms. So notice this will actually have a gap in here. So when I subtract, changing the sign of both of them, first term goes away, this x cubed is hanging in front. So be sure you carry that down. 11x squared minus 144x squared is negative 133x squared. I have 0 x's, and I have minus 4. So now I need to multiply it by x. To turn x squared into x cubed, I need x. And so that's going to become x cubed, and that's going to become 16x. And so now I put that negative in. So the first term goes away. I bring down the negative 133x squared. I bring down the negative 16x and the negative 4. To turn x squared into negative 133x squared, we need negative 133. And so I distribute that and I get negative 133x squared. And now I get negative 133 times 16. And that's negative 2,128. I'm distributing the negative. So I'm going to distribute the negative, and that actually makes them both positives. And so I get negative 16x, and I get plus 2,124. My degree is now 1 versus my divisor had a degree of 2. So this is my remainder. So my final answer is 9x squared plus x minus 133 plus negative 16x plus 2,124 all over x squared plus 16. We are now going to go to the worksheet I've attached to our post on Google Classroom. Okay, so we are going to go to the worksheet I attached to our post on Google Classroom. If you do not have this worksheet on Google Classroom, go ahead and get a separate sheet of paper out if you'd like to write down the problems that we are doing. Okay, so we're going to be doing our 6.5 practice day 1. And we're going to do number 1 and number 5 together. So looking at number 1, I'm going to go ahead and set up my problem. So underneath, I get n cubed plus 2n squared plus 0n plus 3. On the outside, I have n plus 2. To turn n into n cubed, I need n squared. So I distribute that and I get n cubed plus 2n squared. I am subtracting the polynomial, so I distribute that negative to both terms. And notice in this case, they both cancel. So if I bring down what's left over, I have 0n plus 3. But if I multiply n by 0, having a 0 here, that actually is going to go away. So my actual remainder is just 3. 3 is my remainder. So my final answer is going to be n squared plus my remainder of 3 over n plus 2. So notice this answer is not a polynomial. Anytime your final answer has a remainder, you're going to have a variable in the denominator, so it is not a polynomial. Let's take a look at number 5. All right, now I have a 4th degree polynomial divided by a linear polynomial. So I get m to the 4th plus 6m cubed plus 0m squared plus 2m plus 12. And we are dividing this whole thing by m plus 6. So to turn m into m to the 4th, I need m cubed. And so that would become m to the 4th plus 6m cubed. I'm subtracting, so that changes my signs. And in this case, they both cancel out. So I bring down 0m squared plus 2m plus 12. When that leading term has a 0 coefficient, we're going to go ahead and ignore it and just look at 2m plus 12. How do I turn m into 2m? I do that by multiplying it by a positive 2. So then I get 2m plus 2 times 6 is 12. So I get 2m plus 12. Distribute the negative because I'm subtracting the polynomial. And once again, they cancel out and I'm left with 0. Notice this time my remainder is 0. If the remainder is 0, there is no remainder. So my answer is simply m cubed plus 2. Now the reason this would happen is because m plus 6 is a factor of my 4th degree polynomial. So if you were to factor your 4th degree polynomial, you would find m plus 6 to be one of its factors. Anytime you divide a polynomial by one of its factors, it will have no remainder. And so notice that now that I've divided, my answer is a polynomial. So this polynomial divided by this polynomial got a polynomial. When I divided a polynomial by its factor, my result was a polynomial. So notice, polynomials are not closed under division. The result of division is sometimes a polynomial, and it is sometimes not a polynomial. So if you are trying to check if the result of the division of two polynomials is a polynomial, you will have to actually divide it and make sure there is 0 remainder. Okay, so you will actually need to divide it and see if there is 0 remainder. So your homework is to go ahead and finish the worksheet that is posted on Google Classroom.